We conclude this chapter with more definitions. These definitions are the one that you may use or you may need to know in various areas. For example, we define a centered process if you remove the mean of it. So you subtract a random process minus its center, you call it centered random process. We say a random process is asymptotically stationary if in some sense, for instance, in the mean sense, you say mean of x of t is equal to constant, is not a function of time, if limit of d is when t goes to infinity. In that case, you say that x of t is asymptotically stationary in mean sense. Or you say that x of t asymptotically stationary in wide sense if not only this is true but also x of t1 and t2 if limit of these two when t1 and t2 they both go to infinity is equal to x of t1 minus t2 comma 0. So for large values of times they become wide sense stationary. For large values of time, when time goes by, the autocorrelation function becomes only a function of time difference. But for smaller ones, this approximation may not be good. Another definition, nth order stationarity and so on. Or you could say a random process is stationary in an interval. For instance, a speech is stationary in very short time intervals of less than 20 milliseconds. If time t1, t2 are bigger than 20 milliseconds, it's not stationary. That's all. Or stationary increments, you could extend it in different ways and so on. Another class of definitions that you may need, particularly if you work in communication system, wide sense periodic or wide sense cyclostationary. So these two classes are more specific to the case that you have some periodic signals and then they are modulated with a stationary signal, like in the communication system. We call a random process wide sense stationary periodic if two conditions satisfied. First of all, its mean is periodic and its autocorrelation function is periodic in both T1 and T2. Remember that this is not a wide sense stationary. So if wide sense periodic is different with wide sense periodic. Another definition is what called wide sense cyclostationary. This definition is more useful than wide sense periodic. This is the case that first of all the mean is periodic, but the autocorrelation function not only is periodic individually with respect to this one and individually with respect but for both of them. So it's kind of like this one is less restrictive. So if you have this one, you have this one, but not. So this is a bigger class, and this is a smaller class. It's small. If any random process which is wide sense periodic is also wide sense cyclostationary, but not all wide sense cyclostationary processes are wide sense periodic. So this definition is. So here you have to add both multiple factor of t to both arguments in order to have this. So I want you to think about the relationship between these classes. So which one is bigger, which one is smaller, and so. Another definition that is important is mean square periodic and wide sense periodic. So definition, if we say a random process mean square periodic with period of t, if x of t plus t is equal to x of t in mean square sense. So this is like to say that mean of x of t plus t minus x of t to the power of 2 is equal to 0. Any mean square periodic process is also wide-sense periodic. However, there are wide-sense periodic processes which are not mean square periodic. Okay, so mean square periodic is more useful and is more meaningful in practice. And as exercise, you can try to find examples for these two cases. One case which satisfies this one, another case which satisfies this one.